Hi guys, welcome back to CalcFly videos. We're back with another video. In this video, we're going to talk about how to solve question 2 from 2016 AP Calculus for response portion. And this is also a calculated permitted problem. In this problem, we have a given scenario where we have a particle moving along the x-axis and also its velocity is also given. And we have also this given information that we're going to be using later. The particle is at position at x equals 2. The particle is at position at x equals 2 at time t equals 4, which means this is my condition. X of 4 is going to be equal to just 2. So we're going to be using this information later. So let's move on to the questions. In part A, it says at time t equals 4, is the particle speeding up or slowing down? So in order to figure this out, what we need to know, actually what we need to do is, we need to figure out the velocity value at t equals 4, and also we need to figure out the acceleration value at t equals 4. So you can easily figure out this acceleration value at t equals 4 by using the numerical derivative option in your calculator. And let's do it in part A. So the velocity of 4, v of 4 is going to be equal to 1 plus 2 times sine of 8, and this result is going to be equal to just 2.979, which is bigger than 0, which is positive. And acceleration at t equals 4, again, if you use the numerical derivative option in your calculator, because this is calculated permitted problem, and this result is going to be equal to negative 1.164, which is less than 0. So since the velocity and acceleration functions at t equals 4 turned out to be opposite, so what we're going to say as conclusion, the particle is slowing down at t equals 4. So what if velocity and acceleration function came out to be positive, like same sign? So in that case, what we're going to say was this particle is going to speed up at that time. Okay. All right. Let's move on to part B. In part B, it says find all times t in the interval 0 less than t less than 3 when the particle changes direction. So we know that particle changes direction when velocity equal to 0, and also we should be able to observe when the velocity changes sign from positive to negative or negative to positive. So first, we need to set the velocity equal to 0. So when I set the velocity equal to 0, this number is going to, so we're going to come up with this number for t. So t is going to be equal to 2.707. Then we're going to make a number line like this between 0 and 3, and I'm going to put 2.707 right here. And for these two time intervals, sub-time intervals, we need to select values and test them in the velocity function. Okay. So I'm going to select 1 from here, and I'm going to select 2.8 from here. So I'm going to analyze these values in velocity function. So the v of 1 is going to be equal to, using my calculator, actually we are not interested in the numerical value in this case, we are interested in the sign of the result. So the result is going to be positive. Okay. And then a v of 2.8, so if we calculate it, and the sign of this result is going to be equal to just negative. So which means between 0 and 2.707, it's going to be positive, all the way positive until 2.707, and right after that it's going to be negative. Okay, so my conclusion will be this particle is going to change direction at this time, because you see that the velocity is changing from positive to negative at this time. Okay, let's move on to part C. It says find the position of the particle at time t equals 0. Okay. So you know that we can get the position by taking the integral of velocity function. So C is going to be equal to we need to find the position of the particle at time t equals 0. So basically, if I set up this definite integral from 0 to 4 velocity t dt, and using the first fundamental theorem of calculus, this is going to be equal to x of 4 minus x of 0. Okay. So in this case, we need to figure out this x of 0, which is the initial position. Okay. So first, we need to put this definite integral into our calculator and evaluate it. And we already know what x of 4 is equal to, which is equal to 2. So what we need to do is x of 0 is going to be equal to x of 4 minus this definite integral from 0 to 4 vt dt. Okay. And the result is going to be equal to negative 3.815, which means the particle is moving to the negative direction, in the negative direction. Okay. In part D, find the total distance traveled by this particle from 0 to 3. So from 0 to 3, velocity t dt. But in this case, since we're talking about total distance traveled, I need to put absolute value bars around velocity function. And then this is going to be equal to, making good use of the calculator, it's going to be equal to 5.30. Okay. Alright guys, in this video we talked about question 2 from 2016 AP Calculus for Response portion, and mainly we used this particle moving along the x-axis, and then we used its velocity function and tried to figure out if this particle is speeding up or slowing at a specific time, and also we tried to figure out its position, initial position, and also total distance traveled by this particle. Alright guys, if you like this video, don't forget to subscribe, like, share, and comment. See you in the next video, because in the next video I'm going to be explaining question 3 from 2016. See you in the next video. Bye bye.